If you need to conduct a statistical test for your thesis or your first paper, you might be overwhelmed by the large quantity of statistical tests. Why are there so many? How do I choose a test, and how can I be sure to have selected the right one? And also, when reading papers, you might ask yourself if the test selection in the paper is justified. After all, statistical software will produce an output even if you run a test inappropriately. The selection of tests is much easier than one may think. Yes, there are many tests. However, each test can only be applied under specific conditions. It's like selecting a screwdriver. There are so many different types: slotted, Torx, Phillips, hexagonal or Allen, three-wing, and so on. And then there are different sizes. So which one do you choose? The answer is simple. It depends on your screw. It's the same with statistical testing. It depends on your data and the question that you want to answer. The important considerations are: how many groups do I want to compare? What data did I measure? And how were these data obtained? For example, were they paired? We will see in another video what that means. Are my data distributed in a certain way? For example, normally distributed. For some tests, other information may also be relevant. You will be astonished to see that in many cases, for a particular type of data question, there is just one test that fits. So you can't try out different tests until you have a desired result. All of the tests will probably produce a result when you enter your data. However, it is your responsibility to make sure that the test matches your data and question. Let's see an example. Then you will see test selection is not really difficult. You'll find more information on data type, data distribution, and other important questions in future videos. For now, just see that test selection is a simple step-by-step process. Imagine you want to know if there is a difference in the height of girls and boys in primary school. So maybe you have measured the height in 20 children, and now you want to select a suitable statistical test. So this is your data. To find a suitable test, you could, for example, go to web pages such as Wikipedia, where you will find tables with the most common tests and the conditions under which these tests can be applied. We will do the test selection here in the software GSS, because there we can simply follow a flowchart. The first question is, how many groups do we have? We have girls and boys, so it's 2 groups. The next question is about paired data. We will discuss paired data in more detail in another video, but for those who already want to know more, pairing is about whether data is related to each other. For example, when you observe the same patient before and after treatment, then these observations are paired. But don't worry about paired data now. Here we don't have paired data. The next question is about the distribution of the data. Why is the distribution of data so important? Well, there are some tests which are built on the assumption of normally distributed data, and these tests are very precise in detecting differences. These tests are often referred to as parametric tests. But if you don't know how your data is distributed, or if it is not normally distributed, choose non-normal data. Then the choice of tests will be restricted to so-called non-parametric tests. These tests are usually only slightly less sensitive compared to tests assuming normal distribution. For now, we haven't looked at data distribution to keep things simple. So let's try to be on the safe side and choose non-normal data. Now we come to a very important question. What kind of data have you measured? This is important because each test has been designed for a particular data type. There are metric data, such as 3.7 centimeters, 8 kilograms, or minus 14.3 degrees Celsius. And then there are nominal data. These are classes which have a name but no particular order, such as smoker and non-smoker, or the colors green, red, blue. Subjects either belong to one class or to another. Either I'm a smoker or I am not. And then there are ordinal data. Also, these are classes with a name, but they do have an order, such as small, medium, large. In our example, we have measured the height of children, and so we have metric data. So now we come to the last question in this flowchart. Is the distribution of data similar for girls and boys? This question is not relevant for all tests. It is just a specific question for this part of the flowchart. We could have a look at the distribution, but we wouldn't actually expect that the distribution of height in girls and boys would have very different shape. In other words, we would not expect that the variability of height is different in boys and girls. Otherwise, it would be funny. Imagine girls had always almost the same height, but the height of boys varied a lot from small to large. So let's assume similarly distributed data for now. Then we find that Mann-Whitney U-test is the test we should use. That is, for our question and data, the appropriate test is Mann-Whitney U-test. If we were unsure about the similarity of data distribution in girls and boys and wanted to be on the safe side, we could also have chosen Moore's median test. If instead we had looked at the distribution of the data and had found that they are indeed normally distributed, we would have moved up here in the flowchart towards parametric tests, such as two-sample t-test. In summary, each test is linked to specific conditions. The test choice is a simple step-by-step process. Whenever you are unsure if a condition is fulfilled, then better choose the test without the respective assumption. Then we may use a slightly less sensitive test, but at least our test result will not be incorrect. The impact of using an inappropriate test will be much larger.